Now let's talk about the problem of the day. During this time, we'll think together about how to represent and solve this problem and what it teaches us about math. When I ask you questions, please make sure to answer out loud, just like you would in school. So last year, one of my students represented like this. They drew pictures of arrays showing different amounts of rows and flowers in each row, but they always made sure there were 18 total flowers. Because in the story, we don't know how many rows or the amount in each row, but we do know there has to be 18 total flowers. Another student that I had represented like this. They made an equation with two variables, r for rows and k for flowers in each row. Both of these are variables because we don't know either from the story. We do know it has to equal 18 total flowers, so that's what we put as the product of our number sentence. Whether the representation looks like one of these or something else, what do we have to make sure that it shows? Say it out loud. Yeah, it has to show that we don't know how many rows of flowers or how many will be in each row, but that we do know they have to be equal and there has to be 18 total flowers. Okay, so what are we trying to solve here? Say it out loud. Right, we want all the possible ways to make equal rows with 18 total flowers. You might also have said all the possible ways to make equal groups with 18 total, which is also right. Equal rows are one type of equal groups. So, how can we solve it? Say it out loud. Yeah, okay, so some of you probably said that we could draw arrays to find all the possible combinations. And that's true. We could do that. We could draw an array with one row and 18 in each row, an array with 2 rows and 9 in each row, and an array with 3 rows with 6 in each row. If we did that, would we be done? Say it out loud. No? What am I missing? Say it out loud. Oh, right. You could turn each array so that the rows and columns are reversed. So, I could have an array with 18 rows and 1 in each row, 9 rows and 2 in each row, or 6 rows and 3 in each row. All right, cool. And some of you also probably solved just by thinking about your multiplication facts. That also works. You know, we could write 1 times 18 and 18 times 1, 2 times 9 and 9 times 2, or 3 times 6 and 6 times 3. Okay, great. We found all the possible combinations of flowers with 18 total. So how is this similar to what we did yesterday? Say it out loud. Right. It's similar because we're thinking about factors. Factors tell us a way we can break a number into equal groups. But I don't know. It can be tricky to make sure and find all the factors for a given product. So I want to show you a strategy that one of my students showed me that can help us tackle this challenge. This strategy is called a factor rainbow. A factor rainbow is a tool that we use to find all the factors of a given number in an organized way. It's called that because it's shaped like a rainbow. Each arc of the rainbow will represent a factor pair. So I'm going to keep track of how we might use factor rainbows today on this visual anchor chart. What do you think a factor pair is? Say it out loud. You might have said that a factor pair are two numbers that are multiplied together to get a certain product. I want you to read this with me. Get ready? Go. A factor pair is two numbers that when multiplied together result in a certain product. So we're going to test pairs of numbers consecutively and then list factors as we go so that the factors are listed in order from least to greatest along the bottom of the rainbow. Okay, let's try this for the number 18 because in our problem we had 18 total flowers to work with. So first, we want to test the smallest number that could possibly be a factor of 18. What is that number? Say it out loud. Right, 1. Is 1 a factor of 18? Yeah. How do you know that 1 is a factor of 18? Say it out loud. Oh, right, because 1 times 18 equals 18. 1 is a number that you can multiply to get the product 18. So, we're going to make a nice wide arc for our first factor pair. We're going to write 1 on the left and 18 on the right. 18 is the largest possible factor of 18 because there's no number greater than 18 that can be multiplied by any whole number to get 18 as the product. I want you to draw the arc on your scratch paper, just like I'm doing now on the visual anchor. Great. Okay, good. Let's keep testing numbers. What is the next possible factor of 18? Say it out loud. Yeah, 2. We did 1, and 2 is the number right after 1. Is 2 a factor of 18? How do you know? Say it out loud. Yes, 2 is a factor of 18 because 2 times 9 equals 18. So let's draw another arc to show this factor pair. Do this with me on your scratch paper. Write a 2 on the left side of the arc and a 9 on the right side. Okay, what do we try next? Say it out loud. Yeah, 3. Is 3 a factor of 18? How do you know? Say it out loud. Right. 3 is a factor of 18 because 3 times 6 equals 18. Draw another arc with me, showing the factor pair 3 and 6. Okay, what number should we try next? Say it out loud. Right, 4. Is 4 a factor of 18? How do you know? Say it out loud. Right. 4 is not a factor of 18. There is no whole number you can multiply by 4 to get 18. Okay, don't add that to the rainbow. What about 5? Is that a factor of 18? Say it out loud. Yeah, same thing, not a factor. Nothing times 5 equals 18. Ah, this is interesting. The next factor we would check is 6, but that's already in our factor rainbow. What do you think this means? Say it out loud. If you said that we should stop, you're right. We've already checked 6, and we know it's a factor pair with 3. It's already in our rainbow. In fact, our rainbow is done. When there are no more possible factors between the list on the left and the list on the right, it means there are no more possible factors for the number that we're finding factors for. We found all the factors. Go ahead and click the arrow to move to the next slide.